So we're going to start talking about paper folding questions. We will start with 1992, and this question starts with a piece of square paper, which is something we're more familiar with, and because we know the properties of square very well, then it would be a good place to start this kind of question with, okay? All right, so when we do this kind of question, we need to know what kind of paper we started with, okay? And we need to know the properties of the 2D piece of paper that we start with, okay? Because all these properties will be transferred to the 3D object, which is the 3D model later, after we have it stand on the ground, okay? So in this case, ABCD is a thin square metal sheet of side 3 meters. So 3 meters, 3 meters. It's a square. So what are the things that immediately comes to your mind? Obviously, you have all the 4 sides being 3 meters, and there are these 90-degree angles, and you can also find out its diagonal, right? So these are some basic things you can quickly mark on your diagram first. And of course, you know all these like 45 degrees as well. So I'm not gonna write them down, so because you know it already. Let's continue with the description. The metal sheet is folded along BD, and the edges AD and CD of the folded metal sheet are placed on the horizontal plane. So in this case, we know that BD here, all right, is the diagonal. We know its length actually. So we need to transfer these information that we know from one diagram to the other, okay? So we know AD, let me highlight it just to make sure we're clear about which ones are 3s, okay? So the sides of the squares are 3 meters, okay? All right, now continuing. With B, 2 meters vertically above the ground, okay? So BE, okay, let's continue reading this. E is the foot of perpendicular from B, which means that BE is a line that is perpendicular to the ground, okay? So think about it, you stick a pen on your table, okay? So BE is perpendicular to any line that you draw on the table, right? Okay, so we know that this one is 2 meters, okay? This one is 2 meters, all right? Then we can start working, and then we can start like looking at part A, B, C, D. All right, find the length of BD. So BD, we know it already. So a lot of the lengths, we can actually find them just by looking at the 2D figure, okay? Some of the calculation can be done within the 2D figure, for example, BD. Now let's move to ED. Now ED in this case is this one, as a line of the triangle BED. And because we know that BED is a right angle, so finding, and we know BD and BE, it should not be a problem. So you will find ED on the side, okay? And then you will have AE. Now, this time, we don't know these angles, okay? We don't know these angles. We know AD, we know ED. So don't assume any of these angles because the paper has been folded. So we actually don't know what angles has been formed here. So how can you find AE without an angle in this triangle? Then it might not be considering triangle ADE. We have enough information here actually. We know AB, we know BE. How can we find AE? Did you remember what I said about BE? Okay, so you should have enough information. And leave your answers in cert form, okay? All right, now let's find ADE. Now, assuming that you have found DE and AE in part A already, you should be able to find ADE. It should not be a problem. So what are the skills that's been required is, first of all, you need to know what is the original figure, okay? And how these lengths has been transferred to the 3D figure, and you mark them at the correct place, okay? And you need to read from the text and know where are the right angles, because right angles are very important for you to use right angle triangles for calculation. Okay? All right, now coming to part C. Find the angle between BD, okay, and the plane. All right, so it's a line and a plane. You should know how to find it. Also, it should be an easy question because it costs only 2 marks. Last, find the angle between the plane ABD and BCD. Right? Okay, so you know that we need to draw the perpendicular lines, right? And think about it. How is this related to this diagram? When we say we draw a perpendicular line from A to BD, how long is it actually? And what do you see between these two, the top and the bottom triangles? Okay? And the angle between ABD and CBD is actually like quite a standard question, which we have done before. But just make sure that you are finding the correct line. So we know that there's a line here, there's a line here. So how do we close the triangle? It's going to be this one here, right? And you need to think carefully. How are you going to find AC? Okay? And think about it. This structure here, okay, this model here, doesn't it have a symmetrical left and right? Is that going to help you with your calculation? These are all the tiny things that you should factor in. They will help you to do your calculation in like a smoother way.